Okay, guys, we're going to be looking at the first example under the fourth series of examples on projectile. So right here we have an object is projected from a height of 80 meter above the ground with an upward velocity of 40 meter per second at an angle of 30 degrees with the horizontal. What is the time of flight for it to hit the ground? Now, this question was given to some JAM students in 2007 JAM exam. So JAM is one of the major exams given to students who aspire to get admission into the tertiary institutions. So this question was given to them in the year 2007. So how do we solve this? An object being projected from the height of a building. So let's get a picture first. The building could be from the height of 80 meters. It could be a building, it could be anything. But let's assume that this person stayed on the building. Let's assume that it was a building. We are not told that it was a building, but any elevated surface. It could be a building, it could be a mountain, it could be whatever. So the person stays here and projects an object, 80 meters above the ground. That's 80 meters above the ground. This 80 meters above the ground. We know the height where it was projected from. With an upward velocity of 40 meters per second. This initial speed is 40 meters per second at an angle of 30 degrees to the horizontal. Angle of 30 degrees to the horizontal. So what is the time of flight for it to hit the ground? So the object was projected up like this, unlike the other one that was projected down. So for the fact that this body was projected up, it's going to do something like this. It will get to max height, then falls back to where it was projected from, and keeps falling until it gets to the ground, just like this. So this is quite a more complex stuff than the previous one that we worked on. So it gets to a max height, it was projected up like this. So it gets to a max height, and when it gets to a max height, then it starts falling back. So it's going to fall back to where it was projected from, to this angle, to the projection, to the point of projection. So after covering max height, this from here to here, this max height. So after covering max height, then it falls back down to the ground. Since it was not cut at this point. So nobody caught it. So it kept on falling until it dropped to this very point. So we're going to get the total time of flight. Time of flight for it to get the max height, falls back to where it was projected from, and keeps falling down to this very place. So that's what we're going to get. So to get the total time of flight is not a big deal, actually. It's not a big deal. First of all, let's get the components of the initial speed. Let's get them. So it's projected like this. So we have initial speed along x, initial speed along y, 30 degrees here. We have a 40 meters per second. Opposite of our hypotenuse, this u sine theta. We have a u sine theta. So initial speed along y is 40 times sine theta and sine 30 degrees, which is 20 meters per second. Then initial speed along s is 40 times cos 30 degrees. We'll multiply that, know what we're going to get. So 40 times cos 30, that's what we have. 40 times cos 30, 34.64, yeah, 34.64 meter per second. 34.64 meter per second. That's that. So we know what this is. So we can do something. Don't forget that they want us to get the time it takes to complete this whole flight. So we can do this. We can get the time it takes to get to max height. There's a formula for that already. You don't need to go through the rigor of this. You can get the time it takes to get to max height. So at this max height, the final velocity along the y-axis is 0 at max height. So we know that from this very max height, it's going to fall through a distance down to this place. So when we get the distance, the time it takes to get the max height, then we can also calculate the time it takes it to fall from this very point down to this very point. Year to year is 80 meters. So we can get the time, the distance, the max height, we can also get the max height attained and get the max height, get the time to get the max height. So let's do that right away. What's the time, the formula for the time it takes a body to get the max height? Don't forget our formula. We got that formula from V equal to U plus 80. So V along y, initial velocity along y. So final velocity along y is 0. So initial is u sine theta minus gravity t. So the time to get the max height is u sine theta over gravity. That's the time it takes the body to get the max height. So u sine theta is what we have here, which is, you know what u sine theta is? They use 40 times sine theta. That is 20 meter per second over gravity which is 10 meter per second squared. So the time it takes the body to get the max height is, what do we have? Is 2 seconds. It takes the body 2 seconds to get the max height. So it takes this body 2 seconds to fly from here to here, and it's going to take it another 2 seconds to fall back to where it was projected from. So it's going to take it a total of 4 seconds to fall to get to this height and back to this height. So what we're going to get now is how long it's going to take it to come down from this very point down to this very place. But there's an easier method. We know that it takes it 2 seconds to get the max height. So from the max height down to this very portion, we know the height already. The height covers from here to here. So we have to get the max height attained. So then we're going to be able to calculate the time it's going to take it to fall all the way from max height down to where it hits the target here. So let's get the max height. That's what we're going to get. Let's get the max height. Don't forget the formula for max height. The formula for maximum height, H max, is u squared sine squared. We have sine squared. Let's quickly derive that. For max height, so v squared equal to u squared plus 2as, the 0 squared. So u squared sine, we have u sine theta, u squared sine squared theta divided by, that's the mass height here, divided by 2g. That's what we have there. So for mass height of u squared sine squared theta over 2 times gravity. So let's get the max height attained. So initial speed, don't forget that u squared sine squared theta, I said that's u sine theta raised to power 2 over 2 gravity. So u sine theta is 20 meter per second. We've gotten that already. U sine theta, that's initial speed along y-axis. So that's 20 meter per second. That's 20 squared over gravity 2 times 10, which is 20. So 20 times 20 over 20, that will give us 20 meter. That's 20 meter. That's the max height. So from here to here is 20 meter covered. So the max height is 20 meter covered. So from here to here is 20 meters. So from 20 meter, we added to the 80 meters. So the total distance from here down is 100 meters. So max height is 20 meters. So the total distance covered is 100 meters. So if the total distance covered now along the y-axis is 100 meters, and don't forget, at this very junction, what we have here is right here is final velocity. Final velocity is what we have. Final velocity is 0 meter per second. So the body got to the max height, and then gravity sets in and it starts falling back. Now it takes the body 2 seconds to get the max height. So from this very place down to where it's going to hit the ground. So let's see how long it's going to take it, because it's going to cover a distance of 100 meters. Here to here is 20 meters, while from here down to this place is 80 meters. So let's see what we have. Now this final velocity, which is 0 meter per second, immediately gravity sets in, it becomes initial velocity. Because you're going to end up having a new speed which is called the landing speed or the landing velocity. So we have this. Now it's formally 0 meter per second final speed, but now it's an initial speed. We have the distance acceleration along y-axis is 10 meter per second squared, because the body now is falling down. Then the time is going to take it. That's what we are looking for. We are looking for the time. So we have this, we have initial, we have acceleration, we have time. So the next thing we're going to do, let's take off what we have here and keep solving up here. Don't forget, we are asked to get the total time of flight it will take this body to complete the whole projection, the total time of flight. That's what we're about to get. Let's get the total time of flight. So right here, we have a distance, ut, let's go to ut plus half at squared. That's what we have. So the distance is 100 meter covered. So initial speed now, it was formerly final speed, but now is initial velocity. That is 0 times the time we are looking for. We're looking for time. 1 over 2 times acceleration. Now the body is dropping 10. 10 times time, which we are looking for, t squared. So 2 year 1, 2 year, we have 5. That's what we have. So right away, we're getting very close. You're almost there. We're getting very close to what we want. So what do we have? Is gone. So we have 100 equal to 5t squared. So divide both sides by 5. So t squared is 5 in 100 is 20. So we're going to get the square root of 20. The square root of 20 will give us 4.47. That is 4.47 seconds. So it's going to take this body 4.47 seconds to fall down to hit this target. Don't forget, it took the body 2 seconds to get the max height, 20 meters. Now it's going to take it 4.47 seconds to hit this place. So what's the total time of flight? Total time of flight is the 4.47 seconds plus the first that we have. What do we have first? The first time of flight is 2 seconds. That's the time it takes it to get a max height. And from max height all the way down through 100 meters. So that's 4.47 seconds plus 2 seconds. That will give us 6.47 seconds. So it's going to take it about 6.5 seconds, 6.5 seconds to complete this whole journey. So that is that for the very first question under the fourth series of examples. So it's as simple as that. So see you in the next class. Thanks.